Good morning. I am Swaroopa from Marri Laxman Reddy Institute of Technology and Management, working as an assistant professor in data science department. Today, I am going to tell about the topic asymptotic notations and disjoint sets. See, basically, in the asymptotic operations, there will be a big O, big omega, big theta, little o, and little theta. Okay, actually, what do you mean by the big O? Big O is nothing but in the big O there will be some condition. The condition is nothing but f of n less than or equal to c into g of n. Okay, f of n is less than or equal to c into g of n. Whatever we are performing any equations or any conditions by substituting these values, this condition should be satisfied. Okay, first how we are going to satisfy this particular conditions. First, I would like to explain about the big O notation. In the big O notation, the condition is nothing but f of n less than or equal to c into g of n. Suppose if we take this f of n is equals to 3n plus 2 and g of n is equals to n. Okay, in the question only, in the example by itself, they will give the value of the f of n and the value of the g of n. Just what we have to do is just we have to substitute this value and satisfy this particular condition. Okay, by substituting this value, we have to satisfy this particular condition. Here, what is the value of f of n? F of n is equals to 3n plus 2 less than or equals to c into g of n. What is g of n value? N. Okay, g of n value is none. N. Now, what actually we have to do is substitute the n value and the c value. Okay, suppose if you are taking n is equals to 1 and c is equals to 2. Okay, just you substitute this particular values in this particular equation. That is 3 into 1 is 3 plus 2 less than or equal to what is c value? 2 into what is n value? 1. That is 5 less than or equal to 2. Is this condition is true or not? It is false. So this particular value is incorrect for this particular equation. After doing this, again you substitute some other values like n is equals to 2 and c is equals to 2. Now let us see whether this condition is satisfied or not. Just we are going to check whether this condition is satisfied or not. For this, just you substitute n is equals to 2 and c is equals to 2, this particular equation. What is f of n here? 3n plus 2 less than or equals to c into g of n. Okay, what is here n value? 3 into 2, that is equals to 6 plus 2 less than or equals to what is c value? 2 into what is g of n? 2, that is 8 less than or equal to 4. Okay, this particular value is also false. See, here there are the two notations, that is less than, that is equal. We have to check which condition is satisfied or not. Okay, and this is for the equation for the big O of n. And the next one is I am going to tell about the big omega. In the big omega notation, what is the condition here? F of n greater than or equal to c into g of n. Here also what we have to do, just we have to substitute the values. What is f of n value? Actually, in the example only, they will give the value f of n is equals to 3n plus 2 and g of n is equals to n. Now what we have to do, just you have to substitute the values. Okay, here what is f of n? 3n plus 2 greater than or equal to what is c value? C into g of n. Now we have to take n is equal to some one value, c is equals to 2. Now let us check. 3 into 1, that is 3 plus 2 greater than or equal to 2 into 1. Okay, then what you will get here? 5 greater than or equal to 2. Is this condition satisfied or not? Yes, the condition is satisfied. Why? Because here are the two symbols are there, greater than symbol and equal to symbol. We have to check which condition is going to satisfy. Okay, this is about the big omega notation. Next we will go for the big theta. Okay, let us assume for the big theta. For the big theta, what we have to do? First we have to For the big theta, what we have to do? First, we have to see the condition C1 into G of n less than or equals to f of n less than or equals to C2 into G of n. Okay, this is the condition for the theta notation. In a theta notation, there will be a two constants C1 and C2, and there will be F1 and there will be a G1. Okay, these are the two constants. For this, we have to assume f of n is equals to 3n plus 2 and g of n is equals to n and C1 is equals to 1 and C2 is equals to 2. Okay, now you substitute these particular values in the equation. There is 2, for C1, what is the value here? C1 value is 1. C1 value is 1 into what is G of n here? That is G of n is equals to n less than or equal to what is f of n? 3n plus 2. 3n plus 2 less than or equal to what is C2 here? 2. What is G of n? N. Okay, from this, what the values that we have taken, suppose if we take n is equals to 1, that is 1 to 1 into 3 plus 2 less than or equal to 2 into 1. It is 1 into 5 less than or equals to 2. Okay, here the condition satisfy or not? Here the condition is satisfied, that is 1 less than or equal to 5, and the next one is 5 less than or equal to 2. Here the condition does not satisfy, but here the condition satisfy. But these values are wrong. So we have to take the different values. For the different values, we have to check whether this condition is true or not, this condition is satisfied or not. Okay, this is for the big theta notation. Okay, and the next there will be a little o and little omega. Okay, a little omega. For little o, what is the condition? Limit n tends to infinity f of n by g of n. For little theta, limit n tends to infinity g of n by f of n. Okay, these are the conditions for the little omega and the little theta. See, actually these are the 5 conditions for the big O, big omega, big theta, little o and the little theta. Okay, for this we have to substitute the equations. For each and every equations we have to solve up to and until and up to the condition is going to satisfy. Okay, these are the asymptotic notation. Next topic, it's about the disjoint sets. See, what do you mean by disjoint sets? Disjoint set is nothing but in the disjoint set there will be a certain operations will be there. First one is the union operation, and the next one is find operation, and the next one is weighted union, and the next one is collapsing find. See, these are the 4 operations in the disjoint set. Actually, in the disjoint set, we have to solve each and every operation. First, I am going to say about the union operation in the disjoint set. See, what do you mean by the union operation in the disjoint set? What do you mean by the union? Union is nothing but the combining or merging the elements. Suppose if you take 1, 2, 3, 4, 5, 6. Okay, these are the 6 elements. According to the 6 elements, we have to do union operation for this. How we have to do? There are the 6 elements. Each and every step we have to combine the elements. Okay, in the first step, just I am combining this 1 and 2, 3 and 4, 5 and 6. That is 1 comma 2, 3 comma 4 and 5 comma 6. Okay, in the next step, again what we have to do? See, in the union operation, while doing these operations we have to write down the table also. Okay, simultaneously both we have to do. See, for 1 and 2, just we are combining these 2 elements. See, simultaneously we can draw the table here. Okay, simultaneously we have to draw the table here. Here, what is the parent node? For the parent node for the each and every one is -1, -1, -1, -1. See, I have been taken here up to which elements? That is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, these particular elements we have to modify. Here I am taking the parent element. Okay, here 1, 2, 3, 4, 5, 6. Okay, in the next step again we have to combine these particular elements. That is 1, 3. Here only fifth element is there. Okay, here also what we have to do, you have to just combine the elements and you have to modify the table. In the next pith element from 2, what is the parent node of the 2 here? That is 1. What is the parent node of 4 here? That is 3. What is the parent node of 6 here? That is 5. And the remaining all the elements, we can take it as a -1 only. And the next pith element, again you have to combine these particular two elements. That is 1, 2, 3, 4. Okay, again you are going to combine this particular element. Okay, that is 2 to from 2, what is the element here? What is the parent node of a 2? 1. What is the parent node of element 3? 1. Next 4 element 3. Okay, and the next elements are -1, -1, -1. Okay, like this we have to simultaneously update this particular graph in this particular table. And the next step and the last step again 1, 2, 3, 4, 5, 6. Okay, from again you have to update this particular element. What is the 2 parent? That is 1. What is 3 parent? That is 1. What is the 4 parent? That is 3. Next, what is the 6 parent? That is 5. What is the 5 parent? That is 1. What are the remaining elements? 1. Okay, these are the elements that we are doing the simultaneously in the union operation by updating the table. Now we are going to assume the next is find operation. The find operation is nothing but just we are going to find the parent node. Okay, in the find operation just we are going to find the parent node. In the parent node, suppose for the parent node we are just counting and writing the elements. Okay, and the next one is union find, and the next one is weighted union. Weighted union we are just calculating the total number of elements. What are the elements are there? So suppose if the graphs are there 1, so and so 2, 3, 4, 5. Okay, for the weighted union just we are counting the total number of elements in this particular graph. Here for the 1, what is the count of this? 1, 2, 3, 4, 5. Okay, 5, that is -5. Okay, just we are going to count. Suppose if you are taking 5 and 6 here, what is the count of 5 is nothing but -2. We are including all these elements with this particular elements. Okay, and the next one is collapsing find. Collapsing find is nothing but suppose this graph is there. In this graph, we are collapsing the bottom 2 elements and we are write down in the only one particular tree that we are going to write. We are collapsing the remaining elements. Okay, collapsing finding is nothing but we are removing all the bottom elements and we are writing only in the particular graph. These are the disjoint set. Disjoint set is nothing but is consisting of union operation, find operation, weighted union, and the collapsing union. Union is nothing but we are going to merging the elements and we are simultaneously updating the parent element. Whereas the find operation is nothing but just we are finding the parent element of this particular node. Suppose if we are finding the parent element of the 5, we are concluding that the parent element is through 3. By using one algorithm, we are going to find the parent element. And the next one is weighted union. Weighted union is nothing but we are counting the total number of elements in the graph. We are including that particular root node also we are going to calculate. And the next one is collapsing fine. Collapsing fine is nothing but there will be a tree-like structure 1, 2, 3, and 4, 5, 6. Here we are collapsing the bottom of the nodes, and we are write downing all the elements in one particular tree node. One particular tree node that we are doing. Okay, this is all about the disjoint sets. Thank you.